And now in this lecture we'll find out the area of the green shape. In the drawing we have a quarter circle, A or B is a quarter circle, and we also have tangent QP that is tangent to this quarter circle here at this point. BQ equals to 3 units in its length, AP equals to 6 units in its length. This is the angle BQP, that is a right angle. This is the angle APQ. It is also equals to 90 degrees in its size. Again, our mission is to find out the area of this green shape. So first of all, we will define the point of tendency of tangent QP with this quarter circle. This point is point S. And we join points O and S together by straight line. So what is the definition of line segment OS? Line segment OS starts from point O, that is the center of the quarter circle, and ends at point S, that is the point on the quarter circle itself. So this is exactly the definition of a radius. So OS is the radius of the quarter circle. So we define the radius of the quarter circle as X. Write it down. X is the radius of the quarter circle. So OS is the radius of the quarter circle, therefore OS equals to X you can implement here rule 1. Why? Because we have the radius OS of this quarter circle that is drawn to point S, that is the point of tendency of tangent QP with this quarter circle. And whenever a radius that is drawn to the point of tendency, then tangent QP will be perpendicular to the radius SO. If QP is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we will do a construction, that is to say, from point B, we will draw perpendicular on OS. Again, from point B, we will draw perpendicular on OS. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and OS as M. So in the small quadrilateral BMSQ, we have inside the small quadrilateral BMSQ we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of this fourth missing angle. In total, they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. So inside quadrilateral BMSQ we have 4 right angles. Any quadrilateral that has 4 right angles must be this rectangle, if not a square. So we will relate to this quadrilateral BMSQ as a rectangle. Okay, and we also know that the opposite sides of a rectangle are equal to each other. So in rectangle BMSQ, side BQ equals to the opposite side MS. But BQ equals to 3, therefore MS must be also equal to 3 units in its length. So I write it down. MS equals to 3 units in its length. And we also have the rule that the opposite sides of a rectangle are parallel to each other. So in rectangle BMSQ, side BQ is parallel to the opposite side MS. So I write it down. In rectangle BMSQ, side BQ is parallel to the opposite side MS. And then again, in rectangle BMSQ, side BQ is parallel to the opposite side MS. So BQ is parallel to MS, and OS is the radius of this quarter circle. So OS is a radius, it is absolutely a straight line. So OS is a straight line, and part of the straight line OS that is actually MS is parallel to BQ. So part of the straight line OS is parallel to BQ, therefore the straight line OS itself must be also parallel to BQ. So I write it down. The straight line OS itself must be also parallel to BQ. So in quadrilateral OBQS, in this quadrilateral OBQS, side OS is parallel to side BQ, therefore quadrilateral OBQS is a trapezoid. So I write it down. Quadrilateral OBQS is a trapezoid. Why? Because it has one pair of parallel sides, and the definition of a trapezoid is that a trapezoid is a quadrilateral with one pair of parallel sides. What is the length of line segment OM? From the domain it is very easy to see that OM equals to OS minus MS. Again, OS minus MS equals to OM. So I'll write it down. OM equals to OS minus MS. So OM equals to MS. OM equals to OS. So OM equals to OS, and OS is the radius of this quarter circle that's equal to X according to our definition, minus MS. MS is 3. So I completely found out that OM equals to X minus 3 units in its length. OM, this line segment OM is equals to X minus 3 units in its length. In the next step, we will do another construction, that is to say from point A, we will do perpendicular on OS. Again, from point A, we will do perpendicular on OS. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and OS as N. So by doing this construction, we created here quadrilateral ANSP. Inside this quadrilateral ANSP, we have 1, 2, 3 right angles. Therefore, this fourth missing angle must be equal also to 90 degrees. according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral ANSP we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will relate to this quadrilateral ANSP as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANSP, side AP must be equal to the opposite side NS. But AP equals to 6, therefore NS must be also equal to 6 units in its length. So I'm writing down the opposite side NS must be equal to 6 units in its length. NS equals to 6. And we also know that the opposite sides of a rectangle are parallel to each other. So in rectangle ANSP, side AP is parallel to side NS. So I write it down. In rectangle ANSP, side AP is parallel to side NS. Side AP is parallel to the opposite side, side NS. So I repeat again. In rectangle ANSP, side AP is parallel to the opposite side, side NS. So AP is parallel to NS. NS is part of the straight line OS. Again, NS is part of the straight line OS. So part of the straight line OS is parallel to AP. Therefore, the straight line OS itself must be also parallel to AP. Write it down. The straight line OS itself must be also parallel to AP. So, I found out that in quadrilateral OAPS, side OS is parallel to side AP, therefore quadrilateral OAPS is a trapezoid. So I write it down. Quadrilateral OAPS is a trapezoid because it has one pair of parallel sides. So, in conclusion, we found out that quadrilateral OBQS is a trapezoid and quadrilateral OSPA is also a trapezoid. So the sum of the areas of those two trapezoids will be equal to the area of the whole shape in total. The area of the whole shape, that is shape AOBQSP, is equal to the area of trapezoid OBQS plus the area of trapezoid OSPA. Why? Because the whole shape in total consists of those two trapezoids. So the sum of the areas of those two trapezoids, that is trapezoid OBQS plus trapezoid OSPA, will be equal to the area of the whole shape. So what is the length of line segment ON or side ON? From the drawing it is very easy to see that ON equals to OS minus NS. Again, OS minus NS equals to ON. So I write it down. ON equals to OS minus NS. So the length of side ON is equals to OS. OS is the radius of this quarter circle that is equal to X according to our definition minus NS. We have already found out that NS equals to 6. So in total, the length of side ON is equals to x minus 6 units. Side ON the length of side ON is x minus 6 units. So in the next step we'll focus on this right triangle NOA. In the right triangle AON we'll define this angle as alpha. So in the right triangle AON, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So we will define that 90 degrees minus alpha is equals to beta. And therefore, the missing angle here that is equals to 90 degrees minus alpha will be equal to beta. So what is the size of this angle? What is the size of angle MOB? The size of this angle, it will be equal to the big angle AOB, that is equal to 90 degrees, minus this angle, angle alpha. So 90 degrees minus alpha is equal to this missing angle. But 90 degrees minus alpha equals to beta. So you can write here that the missing angle equals to beta. If 90 degrees minus alpha equals to beta, it means that 90 degrees minus beta equals to alpha. If you just add alpha to this equation and then subtract beta, you will get that 90 degrees minus beta equals to alpha. So in the next step, we will focus on this right triangle OBM. In the right triangle OBM, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. What is the definition of line segment OA? Line segment OA starts from point O, that is the center of the quarter circle, and ends at point A, that is the point on the quarter circle itself. This is exactly the definition of a radius. Therefore, OA is the radius of the quarter circle, this quarter circle, is equal to x, according to our definition. Likewise, what is the definition of line segment OB? Line segment OB starts from point O, that is the center of the quarter circle, and ends at point B, that is the point on the quarter circle itself. Therefore, OB is also the radius of this quarter circle, that is equal to x. So in the next step, we'll prove that those two right triangles can go into each other. That is to say, we'll prove that the right triangle ONA, this right triangle ONA, is congruent to this right triangle, triangle OMB. So I write it down. We prove that the right triangle ONA is congruent to the right triangle, triangle OMB. So why those two right triangles can go into each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle ONA in the right triangle ONA, and this is equals to this angle. It is actually angle OMB in the right triangle OMB. So repeat again. Angle ONA in the right triangle ONA equals to angle OMB in the right triangle OMB. They are both equal to 90 degrees, therefore they are equal to each other. In addition, those two angles, they are both equal to alpha, therefore they are equal to each other. So this is angle AON in the right triangle ONA, and it is equals to this angle, the actual angle OBM in the right triangle OMB. Repeat again. Angle AON in the right triangle ONA is equals to angle OBM in the right triangle OMB. They are both equal to alpha, therefore they are equal to each other. And we have those two angles, they are both equal to beta, therefore they are equal to each other. So actually this is angle OAN in the right triangle ONA, and it is equals to this angle, that is actually angle BOM in the right triangle OMB. So repeat again. Angle OAN in the right triangle ONA is equals to angle BOM in the right triangle OMB. They are both equal to beta, therefore they are equal to each other. So we actually proved that all the three angles in the right triangle ONA are correspondingly equal to all the three angles in the right triangle OMB. This right triangle OMB. And finally, side OA in the right triangle ONA is equal to side OB in the right triangle OMB. They are both the radii of the quarter circle that is equal to x, therefore they are equal to each other. So I repeat again. Side OA in the right triangle ONA is equal to side OB in the right triangle OMB. They are both the radii of the circle, they are both the radii of the quarter circle that is equal to x, therefore they are equal to each other. So I actually proved that the right triangle ONA is congruent, this is the sign of congruent, to the right triangle OMB according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles and the side that included between the two angles in one triangle are correspondingly equal to two angles and the side that included between the two angles in a second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. And here we proved that those two angles alpha and beta and the angle and the side that included between those two angles, that is side OA in the right triangle ONA, are correspondingly equal to those two angles that are also alpha and beta, and the side that included between those two angles, that is actually side OB in the right triangle OMB. Therefore we proved that those two right triangles can go into each other according to angle side angle rule. Okay, and from the fact that those two right triangles can go into each other, we will derive that side ON in the right triangle ONA is equal to side MB in the right triangle OMB. Repeat again. We derive that ON equals to NB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides, that is to say ON and NB, must be also equal to each other. But we have already found out that ON equals to x minus 6. ON equals to x minus 6. So you can write here that ON equals to x minus 6. And from this equation, x minus 6 equals to ON equals to MB. We will derive that MB is also equals to x minus 6 units in its length. So this is side MB. That is equals to x minus 6 units in its length. So you can also conclude from the fact that those two right triangles can go into each other, that side OM in the right triangle OMB is equal to side NA in the right triangle ONA. Repeat again, side OM is equal to side NA. Again, you can also conclude that side OM equals to side NA. But we have already found out that OM, this is side OM, is equal to x minus 3. Okay, so we can write here that OM equals to x minus 3, and for this equation x minus 3 equals to OM equals to NA. We will derive that NA is also equal to x minus 3 units in its length. This side NA is equal to x minus 3 units in its length. So in the next step, I will copy the right triangle ONA in a new page, and we will implement on this right triangle ONA the Pythagoras theorem. So we just now found out that NA equals to x minus 3 units, and we already found out that ON equals to x minus 6 units in its length, and the hypotenuse OA equals to x, it is also the radius of the quarter circle. So actually this is the right triangle ONA that I copied from the original drawing. By PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ONA is OA, therefore the square of the hypotenuse is OA squared, and it must be equal to ON squared plus NA squared. Okay. OA equals to x, therefore OA squared is x squared, and it is equals to ON squared. ON is x minus 6, therefore ON squared is x minus 6 squared plus NA squared. NA is x minus 3, therefore NA squared is x minus 3 squared. In conclusion, found out that x squared equals to x minus 6 squared plus x minus 3 squared. So here we'll open the brackets on this side of the equation and we get that x squared equals to x minus 6 squared. X minus 6 squared equals to x squared plus 6 squared, that is 36, minus 2 times x times 3, that is minus 12x, plus, plus x minus 3 squared. X minus 3 squared equals to x squared plus 3 squared, that is 9, minus 2 times x times 3, that is minus 6x. So here we have x squared on both sides of the equation, so x squared will get cancelled. After we cancel the x squared, in this side of the equation we left with nothing, that is to say 0. That is equals to, in the other side of the equation we have 36 plus 9, that is 45. We have here minus 12x, minus 6x, that is minus 18x. Plus x squared. In conclusion, found out that x squared minus 18x plus 45 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we'll find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now a specific quadratic equation x squared minus 18x plus 45 equals to 0. The coefficient a equals to 1. The coefficient b equals to minus 18. And the coefficient c equals to 45. So we have to put the data inside this general formula for x, and we'll find out the value of the values of x. We'll do it now, and we'll get that x equals to minus b. B is minus 18, therefore minus b is minus 18, that is plus 18, plus minus square root of b squared. B is minus 18, therefore b squared is minus 18 squared, that is 324. Minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, that is 45. So minus 4 times 45 is minus 180, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. In conclusion, found out actually that x equals to 18 plus minus the square root of 324 minus 180 is 144, so inside the root we left only with 144 divided by 2. So x equals to 18 plus minus the square root of 144 is 12 over 2. So here we will have two solutions that are possible for x. And the first solution for x is that x equals to 18 plus 12 over 2. 18 plus 12 is 30, and 30 over 2 is 15. So the first solution for x is that x is equals to 15 units in its length. And we have also a second solution that is possible for x. X also could be equal to 18 minus 12 over 2. 18 minus 12 is 6, and 6 over 2 is 3. So the second solution for x is that x equals to 3. But this solution is incorrect solution. Why? Because we already found out that the length of this side BM is equals to x minus 6. So BM equals to x minus 6. BM is a length, and as a length it must be a positive number, and the length of BM is x minus 6. So the length x minus 6 must be a positive number. That is to say, it must be greater than 0. If x minus 6 is greater than 0, it means that x is greater than 6. So actually found out that x must be greater than 6. If x must be greater than 6, it can never be equal to 3, that is less than 6. So this solution, x equals to 3, is incorrect solution, and we cancel the solution, and we're left only with the first solution that is possible for x. That is to say, x equals to 15 units in its length. Here, O8 is equal to x is equals to 15 units. OB that is also equals to x is also equals to 15 units. And QS equals to x minus 6. X is 15, so x minus 6 is 15 minus 6, that is 9. And we have SP is equal to x minus 3. X minus 3 is 15 minus 3, that is 12. Okay, and OS is also equals to x, and x equals to 15. So, in the next step, I present to you what is the formula for the area of any trapezoid. I remind you that a trapezoid is a quadrilateral with one pair of parallel sides. So we have here quadrilateral ABCD. This is quadrilateral ABCD. This quadrilateral ABCD, side AD is parallel to the opposite side BC. For that reason, quadrilateral ABCD is defined as a trapezoid. The two parallel sides, that is to say AD and BC, are defined as the bases of the trapezoid. So side AD is the first base, and side BC is the second base. So what is the area of this trapezoid ABCD? The area of trapezoid ABCD is equals to the sum of its bases. That is to say, it is AD plus BC. Times the height. We define the height as h, so it is times h. The height h must create 90 degrees with the two bases. So if side CD creates 90 degrees if those two bases AD and BC, then the height will be DC. But if DC doesn't create 90 degrees with the two other bases, then we'll do perpendicular on AD or on BC. The perpendicular on AD will be also perpendicular to BC because AD is parallel to BC. And the perpendicular will be the height to the base. Okay, and then again, the height must get 90 degrees with the base. If side CD doesn't get 90 degrees with the two bases AD and BC, we just go perpendicular on one of the bases, and the perpendicular will be the height to the base. So it is times h, that is the height to the base, divided by 2. In conclusion, we found out the area of trapezoid ABCD, it could be any trapezoid. It is equal to the sum of its bases, that is to say AD plus BC times the height to the base. The height must create 90 degrees with the base divided by 2. Okay, so what is the area of the green shape? The area of the green shape will be equal to the area of the whole shape, minus the area of this quarter circle OAB, minus the area of the quarter circle A or B. It is very easy to see that the area of the whole shape minus the area of this quarter circle A or B will be equal exactly to the area of this green shape, that is the area that we are looking for. But because of the fact that the area of this whole shape, or this whole shape, consists of those two trapezoids, so the area of the sum of the areas of those two trapezoids will be equal to the area of the whole shape. So the area of the whole shape equals to the area of trapezoid ASQB or OSQB plus the area of this trapezoid OSPA. I repeat again, the sum of the areas of those two trapezoids, that is to say the area of trapezoid OSQB plus the area of trapezoid OSPA, in total the sum of the areas of those two trapezoids will give us the area of this whole shape, and the area of this whole shape minus the area of this quarter circle A or B will be equal exactly to the area of this green shape, that is the area that we are looking for. So the area of trapezoid OSQB plus the area of trapezoid OSPA minus the area of the quarter circle A or B will be equal to the area of the green shape. So, what is the area of trapezoid OBQS? The area of this trapezoid OBQS is equals to the sum of its bases, that is actually BQ plus OS, times the height. Because of the fact that QS creates 90 degrees with the two bases, QS is the height. So it is times QS over 2 plus the area of trapezoid OSPA. What is the area of this trapezoid OSPA? The area of trapezoid OSPA equals to the sum of its two bases, that is OS plus AP, times the height. The height must create 90 degrees with the two bases. And because of the fact that side SP creates 90 degrees with the two bases AP and OS, SP is the height to the base divided by 2 minus the area of the quarter circle AOB. The area of this quarter circle equals to the area of the circle over 2. The radius of the circle and also the radius of the quarter circle is x. Therefore, the area of the circle is pi x squared. So pi x squared, that is the area of the circle over 4, is the area of this quarter circle AOB. So the area of trapezoid OSQB equals to BQ plus OS. BQ is 3 plus OS, that is 15. It is the radius of the quarter circle, that is x, and x is 15, times QS. QS equals to 9. This is the height, is equals to 9 divided by 2. In conclusion, found out that the area of trapezoid OSQB equals to 3 plus 15 times 9 over 2. So 3 plus 15 is 18. 18 over 2 is 9, and 9 times 9 is 81. In conclusion, found out that the area of trapezoid OSQB is equals to 81 square units plus the area of trapezoid OSPA. The area of this trapezoid OSPA equals to OS, that is 15, plus AP, that is 6, times SP. SP equals to 12 divided by 2. So 15 plus 6 is 21, and 21 times 12 over 2 is 6. So 21 times 6 is 126. In conclusion, we found out that the area of trapezoid OSPA is equal to 126 square units minus the area of quarter circle AOB. The area of the quarter circle AOB equals to pi x squared over 4. So it is pi. X is 15, therefore x squared is 15 squared. It is 225 over 4. In conclusion, we found out that the area of the quarter circle AOB equals to 225 pi over 4. 225 over 4 is equals to 176.716 square units. So the area of the green shape equals to 81 plus 126. That is actually the sum of the areas of those two trapezoids. So 81 plus 126 is 207. So the sum of the areas of those two trapezoids, that is actually the area of the whole shape, is equal to 207 square units minus the area of the quarter circle AOB, that is 176.716. So 207 minus 176.716 716, it is equals to 30.285 square units. In conclusion, found out that the area of the green shape is equals to 30.285 square units. Repeat again, the area of this green shape is equals to 30.285 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this green shape. So, in the drawing, we have a quarter circle. A or B is a quarter circle. And we have also tangent QP that is tangent to this quarter circle here at this point. In addition, we have also line segment AP that is equals to 6 units in its length. Line segment BQ equals to 4 units in its length. This is angle BQP, that is a right angle, and this is angle APQ, that is also equals to 90 degrees in its size. Again, our mission is to find out the area of this green shape. So, in the first step, we define the point of tendency of tangent QP with this quarter circle, this point as point S. Then we join points O and S together by set line. What is the definition of line segment OS? Line segment OS starts from point O, that is the center of the quarter circle, and then at point S, that is the point on the quarter circle itself. So this is exactly the definition of a radius. So OS is the radius of the quarter circle. We define the radius of this quarter circle as x. Here x is the radius of the quarter circle, therefore OS equals to x, because it is the radius of the quarter circle. Okay? Here we implemented rule 1. We have the radius OS that is drawn to point S, that is the point of tendency of tangent QP with this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent QP will be perpendicular to the radius SO. If QP is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we did the construction, that is to say, from point B, we draw perpendicular on OS. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and OS as M. So by doing this construction, we created the small quadrilateral BMSQ. Inside this small quadrilateral BMSQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus this fourth missing angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So the missing fourth angle here must be equal to 90 degrees in its size. So inside the small quadrilateral BMSQ we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral BMSQ as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle BMSQ, side BQ must be equal to the opposite side MS. But BQ equals to 3, therefore MS must be also equal to 3 units in its length. And we also know that the opposite sides of a rectangle are parallel to each other. So in rectangle BMSQ, side BQ must be parallel to the opposite side MS. Repeat again. In rectangle BMSQ, side BQ must be parallel to the opposite side MS. So here BQ is parallel to MS. OS is the radius of this quarter circle that is equal to x. So OS is a radius, it is absolutely a straight line. OS is a straight line and MS is part of the straight line OS. So part of the straight line OS is parallel to BQ, therefore the straight line OS itself must be also parallel to BQ. So the straight line OS itself must be also parallel to BQ. So actually found out that in quadrilateral OBQS, side OS is parallel to side BQ, therefore this quadrilateral OBQS is a trapezoid. Quadrilateral OBQS is a trapezoid. Why? Because it has one pair of parallel sides. And the definition of a trapezoid is a quadrilateral with one pair of parallel sides. So quadrilateral OBQS is a trapezoid. In the next step, we found out the length of this line segment OM. From the drawing, it is very easy to see that OM equals to OS minus MS. Again, OS minus MS equals to OM. Here, OM equals to OS minus MS. OS is the radius of the quarter circle that's equal to X minus SM equals to 3. So in total, OM equals to X minus 3. Here, OM equals to X minus 3. In the next step, we did another construction, that is to say, from point A, we draw perpendicular on OS. Again, from point A, we draw perpendicular on OS. So this again equals to 90 degrees, and this again equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and OS as N. By doing this construction, we created quadrilateral NAPS. Inside this quadrilateral NAPS, we have 1, 2, 3 right angles. Therefore, this fourth angle must be also equal to 90 degrees. So inside this quadrilateral NAPS, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a left angle, if not a square. So we relate to this quadrilateral NAPS as a left angle. And we also know that the opposite sides of a left angle are equal to each other. That is to say, in left angle NAPS, side AP must be equal to the opposite side NS. But AP equals to 6, therefore NS must be also equal to 6 units in its length. Here NS equals to 6. Likewise, we also know that in the opposite sides of a left angle are parallel to each other. So in left angle NAPS, side NS must be parallel to side AP. Repeat again. In left angle SP, side AP must be parallel to the opposite side, side NS. So here AP is parallel to NS. But NS is part of the straight line OS. So part of the straight line OS is parallel to AP, therefore the straight line OS itself must be also parallel to AP. Okay? The straight line OS itself must be also parallel to AP. So in quadrilateral OSPA, side OS is parallel to side AP, therefore quadrilateral OSPA is a trapezoid. Quadrilateral OAPS is a trapezoid because it has one pair of parallel sides. In conclusion, found out that OBQS is a trapezoid and OSPA is also trapezoid. So actually this shape, the whole shape in total consists of those two trapezoids. And therefore the area of the whole shape in total, shape OAPSQB, the area of this whole shape will be equal to the sum of the areas of those two trapezoids. Trapezoid OBQS plus the area of trapezoid OSPQ. Okay? So, in the next step, we found out the length of this line segment ON. What is the length of ON? from the drawings it's very easy to see that ON equals to OS minus NS. Again, OS minus NS equals to ON. Again, ON equals to OS minus NS. OS is the radius of this quarter circle that's equal to X, and NS equals to 6. Here NS equals to 6, so ON equals to X minus 6. Here ON equals to X minus 6. In the next step, we focused on this right triangle, triangle AON. Triangle AON. In the right triangle AON, we define this angle as alpha. So this angle equals to alpha. In the right triangle AON, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this missing angle must be equal to 90 degrees minus alpha, according to the rule that the sum of the angles in any triangle is equals to 180 degrees. This missing angle equals to 90 degrees minus alpha. We defined 90 degrees minus alpha as beta, therefore the missing angle here equals to beta. Okay, what is the size of this missing angle? Angle BOM. The size of this missing angle must be equal to angle AOB, that is the right angle according to what is given us the question, minus this angle, that is angle alpha. So 90 degrees minus alpha is the size of this missing angle. But 90 degrees minus alpha equals to beta. Therefore, the size of this missing angle is beta. So in the right triangle OBM, this angle equals to beta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle equals to alpha. What is the length of line segment OA? Line segment OA starts from point O, that is the center of the quarter circle, and then at point A, that is the point of the quarter circle itself. This is exactly the definition of a radius. So OA is the radius of the quarter circle, is equal to X units in its length. Likewise, what is the length of line segment OB? Line segment OB starts from point O, that is the center of the quarter circle, and then at point B, that is the point of the quarter circle itself. Therefore, OB is also the radius of this quarter circle, that is equal to X. In the next step, we proved that those two right triangles can congruent to each other. That is to say, we proved that the right triangle ONA is congruent to this right triangle, triangle ONB. So why those two right triangles can congruent to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, those two angles are both equal to alpha, therefore they are equal to each other. And those two angles are both equal to beta, therefore they are equal to each other. So, in conclusion, we found out that all the three angles of the right triangle ONA are correspondingly equal to all the three angles on this right triangle ONB. And finally, side OA in the right triangle ONA is equals to side OB of the right triangle ONB. They are both the radii of the quarter circle that is equal to X, therefore they are equal to each other. So we actually proved that those two right triangles can go into each other according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove the two angles and the side that included between the two angles in one triangle are correspondingly equal to two angles and the side that included between the two angles in a second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. And here we proved that those two angles, that is to say alpha and beta, and the side that included between those two angles, that is actually side OA in the right triangle ONA, are correspondingly equal to those two angles that are also alpha and beta, and the side that included between those two angles, that is side OB in the right triangle OMB. So therefore we proved actually that those two right angles can go into each other according to angle side angle rule. We have those two angles and the side that included between those two angles in the right triangle ONA are correspondingly equal to those two angles, and the side that included between those two angles in the right triangle OMB. Therefore, those two right angles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side ON equals to side MB. Repeat again, we will derive that side ON equals to side MB. Side ON equals to side MB, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say ON and BM, must be also equal to each other. But we have already found, that is to say ON and BM must be also equal to each other. So, but we have already found out that ON equals to x minus 6. So we can write here that ON equals to x minus 6, and from this equation x minus 6 equals to ON equals to BM, we will derive that BM or MB also equals to x minus 6. So this side BM equals to x minus 6. And we can also conclude from the fact that those two right triangles can go into each other, that side OM in the right triangle OMB is equal to side NA in the right triangle AON. And again, we conclude that side OM equals to side AN. But we have already found out that OM equals to x minus 3. Here, OM equals to x minus 3. So we can write here that OM equals to x minus 3, and from this equation x minus 3 equals to OM equals to AN, we will derive that AN is also equals to x minus 3. This side AN equals to x minus 3 in its length. In the next step, I copied the right triangle ONA in a new page, and we implemented on this right triangle ONA the Pythagoras theorem. So this is the right triangle ONA that I copied from the original drawing. ON equals to x minus 6, NA equals to x minus 3, and the hypotenuse OA equals to x. This is the radius of the quarter circle that is equal to x. Here by PT is a version for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ONA is OA, therefore the square of the hypotenuse is OA square, and it must be equal to ON square plus AN square. OA is x, therefore OA square is x squared, and it is equal to ON square. ON is x minus 6, therefore ON square is x minus 6 squared, plus AN square. AN is x minus 3, therefore AN square is x minus 3 square. In conclusion, we found out that x square equals to x minus 6 square plus x minus 3 square. Here we open the brackets on this end of the equation and found out that x square equals to x minus 6 square. X minus 6 square equals to x square plus 6 squared, that is 36, minus 2 times x times 6, that is minus 12x, plus x minus 3 square. X minus 3 square equals to x square, plus 3 squared, that is 9, minus 2 times x times 3, that is minus 6x. Here we have x square on both sides of the equation, so x square will get cancelled. In this side of the equation we left with nothing, that is to say 0. This is equals to, here we have 36 plus 9 is 45, and we have also minus 12x minus 6x, that is minus 18x, plus x squared. In conclusion, we found out actually that x squared minus 18x plus 45 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here, in this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared minus 18x plus 45 equals to 0, the coefficient a equals to 1, the coefficient b equals to minus 18, and the coefficient c equals to 45. Okay. A equals to 1, B equals to 18, and C equals to 45. So we put this data inside the general formula, and found out the values of x. according to this general formula, x equals to minus b. b is minus 18, therefore minus b is minus 18, that is plus 18, plus minus square root of b squared. b is minus 18, therefore b squared is minus 18 squared, that is 324, minus 4 times a times c. Minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, that is 45. So minus 4 times 45 is minus 180, divided by 2a. a is 1, so 2 times a is 2 times 1, that is 2. So x equals to 18 plus minus square root of 324 minus 180 is 144, so inside the root we left only 144 divided by 2. So x equals to 18 plus minus the square root of 144 is 12 over 2. So x equals to 18 plus minus 12 over 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to 18 plus 12 over 2. 18 plus 12 is 30 and 30 over 2 is 15. So according to the first solution, x equals to 15, and we have also the second solution that is possible for the value of x. X could be also equal to 18 minus 12 over 2. 18 minus 12 is 6 and 6 over 2 is 3. But this second solution is the correct solution. Why? Because we found out that the length of this line segment BM or side BM is x minus 6. So here BM equals to x minus 6. So BM is a length. It is the length of the line segment BM. So BM is as a length, it must be a positive number. That is to say BM is equal to x, that is a length, it must be a positive number. That is to say, it must be greater than 0. So x minus 6 is greater than 0, it means that x must be greater than 6. So x must be greater than 6, but if x equals to 3, x is less than 6. Therefore x can never be equal to 3, because x must be greater than 3 and 3 is less than 6. So cancel this solution, x equals to 3, and we left with the only one solution that is possible for x equals to 15. So here x equals to 15, or A, that is x equals to 15, or B, that is x also equals to 15. QS is x minus 6, that is 15 minus 6, that is 9. SP is x minus 3, that is to say it is 15 minus 3, that is 12. O is x, that is 15, and OS is also x, that is equals to 15. In the next step, I actually presented to you the formula for the area of any trapezoid. Here, quadrangle ABCD is a trapezoid. Why? Because it has one pair of parallel sides. Side AD is parallel to side BC. The definition of a trapezoid is a quadrangle with one pair of parallel sides. In this quadrangle ABCD, side AD is parallel to side BC. For that reason, quadrangle ABCD is a trapezoid. The two parallel sides, that is to say AD and BC, are defined as the bases of this trapezoid. So the first base is AD and the second base is BC. So the area of this trapezoid ABCD, that could be any trapezoid, equals to the sum of its bases, that is to say it is AD plus BC, times the height to the base. The height to the base must create 90 degrees with the base. If side CD creates 90 degrees with the two other bases, then the height will be DC, but if not, then we'll just draw perpendicular to one of the bases, and the perpendicular will be the height to the base. So the height is h. So the height would be DC or a perpendicular to one of the bases. So it is h divided, the height that is h divided by 2. In conclusion, the area of any trapezoid equals to the sum of its bases. In this case it is AD plus BC times the height to the base that must create 90 degrees with the base. The height is h divided by 2. So what is the area of this green shape? The area of this green shape equals to the area of the whole shape. But this whole shape consists of those two trapezoids. So the sum of the areas of those two trapezoids will be equal to the area of the whole shape minus the area of this quarter circle AOB. Repeat again, the area of the green shape equals to the area of the whole shape in total minus the area of the quarter circle AOB. But because of the fact that the whole shape consists of the two trapezoids, trapezoid OSQB and trapezoid OSPA, the sum of the areas of those two trapezoids will be equal to the area of the whole shape minus the area of the quarter circle AOB. What is the area of trapezoid OSQB? The area of this trapezoid OBQS, it is equal to the sum of its bases, that is BQ plus OS, BQ plus OS, times the height to the base, that is QS. Why the height is QS? Because the QS creates 90 degrees with the two bases. So it is times the height, that is QS, over 2. BQ is 3, OS is 15, and QS is 9 divided by 2. 3 plus 15 is 18. 18 over 2 is 9, and 9 times 9 is 81. In conclusion, found out that the area of this trapezoid OBQS is 81 square units, plus the area of trapezoid OSPA. What is the area of this trapezoid OSPA? Is equal to the sum of its bases, that is OS plus PA, and OS plus PA, times the height, that is SP. Why the height is SP? Because the height, SP creates 90 degrees with the two other bases. So times SP over 2. OS is 15, AP is 6, SP is 12 divided by 2. 15 plus 6 is 21, 12 over 2 is 6, and 12 over 2 is 6, so 21 times 6 is 126. In conclusion, found out that the area of this trapezoid OSPA is 126 square units. So it is 126 square units minus the area of this quarter circle AOB. What is the area of this quarter circle AOB? The area of any quarter circle equals to the area of the circle over 4. The area of the big circle with radius x is pi x squared. So it is pi x squared over 4. This is the area of the quarter circle AOB. X is 15, x squared is 15 squared, that is 225. And therefore, the area of the quarter circle AOB equals to 25 pi over 4. 25 pi over 4 is 176.716 square units. So 81 plus 126, it is the sum of the areas of those two trapezoids, and the sum of the areas of those two trapezoids, it is equal to the area of the whole shape. So the area of the whole shape, it is 81 plus 126, that is 207. So the area of this whole shape equals to 207 square units minus the area of this quarter circle. And we have already found out that the area of the quarter circle equals to 176.716 square units. So the area of the whole shape, that is 207 square units, minus the area of this quarter circle AOB, that is 176.716, equals to the area of the green shape. So 207 minus 176.716 is equals to 30.285. So the area of this green shape, in total, it is equals to 30.285 square units. Okay? Repeat again, the area of this green shape equals to 30.285. The area of this green shape, in total, it is equals to 30.285 square units. Okay? Thank you very much.